Hello everyone, now we'll study chapter 3 of NCRT pair of linear equation in two variables. But before starting this chapter, let us recall what we have learned in class 9. Linear equation in two variables, already you have learned in class 9 that a linear equation in two variable is an equation of the form ax plus by plus c equal to 0, where a, b and c are the real numbers and a and b are not both zeros. One of the example is given here, 2x minus 3y plus 4 is equal to 0. This is an equation and it contains two variable and the degree is 1. That is why this is called a linear equation in two variable. Second, the solution of a linear equation in two variables. This also you have learned in class 9. A pair of values, one for x and the other for y, which makes the two sides of a linear equation equal, is called its solution. So pair of values, one for x, one for y, which satisfies this equation will be the solution. For example, here x equal to m, y equal to n, satisfying the equation. So this means pair m comma n is called the solution of the equation. Next, we have the geometrical meaning of a solution. Geometrically, you all know that a linear equation in two variable always represent a straight line. So let us take one of the example here. Consider this linear equation in two variable, x plus 2y is equal to 6. These are the solutions of this linear equation. Now plot these coordinates 0 comma 3 here, 2 comma 2, 4 comma 1, and join these coordinates. You will observe that you will get a straight line. So geometrically, the graph of a linear equation always represent a straight line. Now all the points on this straight line, because it will have infinitely many points, all the points on this straight line will be the solution of this linear equation, and vice versa. It means all the solution of this linear equation in two variable will lie on this straight line. Now we'll learn about the pair of linear equation in two variables. Watch this video, observe the situations and try to understand a pair of linear equation in two variables.
Observe these real-life situations. Joe and Alice have both come to city store. Joe buys 3 cricket balls of the same price for his upcoming match by paying an amount of rupees 60 to the shopkeeper. What price do you think Joe paid for each ball? We can mentally work out the steps, but for actual computation, it is more convenient to use algebra. Let us denote the price of one ball as rupees x. So 3x is equal to 60. Solving for x, we get price of each ball as equal to rupees 20. So Joe pays rupees 20 for each ball. Alice buys a doll and 3 hats for rupees 120. Find the price of the doll and the hat. Let us denote the price of doll as x and the price of the hat as y. Using the facts, we can form the equation x plus 3y is equal to 120. Consider this as equation 1. But this does not help us in getting the price of the hat or the doll. There may be many combinations of x and y which can satisfy this equation.
Why were we able to find the price of the ball but not able to find the price of the hat or the doll?
In the first case, we had one unknown represented by one equation, so we could find the value. But in the second situation, we have two unknowns and one relation between them given by the equation x plus 3y is equal to 120. So we were not able to find the value. What is required to solve the second scenario? We need another relationship between the two variables x and y. If we get another fact that the price of the doll is equal to the price Alice paid for 3 hats, this can be represented as x is equal to 3y. Consider this as equation 2. Now, substituting equation 2 in 1, we get 3y plus 3y is equal to 120, or 6y is equal to 120, or y is equal to 20. Substituting the value of y in equation 2, we get x is equal to 3 into 20, that is equal to 60. So, the price of the doll is rupees 60 and the price of the hat is rupees 20. Each of the equation 1 and 2 is of the form ax plus by plus c is equal to 0, where a, b and c are real numbers and a and b are not zeros. This equation is called a linear equation in two variables x and y. Since both the equations are in the same variables x and y, they are called a pair of linear equations in two variables. The value of x is equal to 60 and y is equal to 20 is a solution of the pair of linear equations. The general form for a pair of linear equations in two variables is a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0, where a1, b1, c1, a2, b2 and c2 are real numbers and a1 square plus b1 square is not equal to 0 and a2 square plus b2 square is not equal to 0.
So now you have learned that what are pair of linear equations in two variables and why pair of linear equations in two variables required. Now, the general form of a pair of linear equations in two variables x and y is as follows: a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 is equal to 0. These two linear equations in variables x and y together they form a pair of linear equation where a1 b1 c1 a2 b2 c2 are all real numbers and a1 square plus b1 square should not be equal to 0, a2 square plus b2 square should not be equal to 0. This is known as the algebraic representation of a system of simultaneous linear equation in two variables. Now we learn about the solution of a pair of linear equation in two variable, a pair of values of x and y satisfying each of the equation in a given system of linear equations in two variables. Let us take this example to understand the meaning of the solution of a pair of linear equation. Consider this pair of linear equation 2x plus 5y minus 16 is equal to 0, 7x minus 3y minus 15 is equal to 0. Now 3 comma 2, this pair satisfies first equation and the same this ordered pair 3 comma 2 satisfies the second equation also. So this implies that 3 comma 2 is a solution of the given pair of linear equations in two variable. So you have observed that a pair of values x comma y which satisfying both the equations is a solution of the pair of linear equations in two variables. Now, pair of linear equations, the solution can be find out by the two ways, the graphical method and the algebraic method. We will discuss both the methods later. Now, we have the graphical representation of the linear equations. So let us now see that what a pair of linear equation two variables look like graphically. As you all know that the linear equation in two variable represent a straight. So a pair of linear equation in two variable will be represented by two straight lines both to be considered together. So when we draw two straight lines together, there can be three possibilities. Try to understand all these three possibilities. Case number one, when we draw the two straight lines together in the same graph paper, this can be the case when the two straight lines intersect at one point. Then in that case, this point, the intersection point, will be the solution of a pair of linear equations. Case number two, this can be the case when we draw two straight line in the same graph paper. then the two straight lines are parallel. It means the two straight lines will never intersect. In that case, there will not be any intersection point between the two straight lines. It means the pair of linear equation will have no solution. Third, case number 3, the two lines will coincident. It means the one line overlap the other line. In that case, all the points on the straight line will be the solution of a pair of linear equation. And as you know that there are infinitely many points on this line, so in this case a pair of linear equation will have infinitely many solutions. Now watch this video and try to understand the graphical solution to a pair of linear equation in two variable.
Let us take a look at the pair of linear equations from the last example again. X plus 3y is equal to 120. X is equal to 3y or x minus 3y is equal to 0. We will now plot these equations on the graph. Let us take the first equation, x plus 3y is equal to 120, and compute different values of y for different values of x and tabulate the same. We plot the corresponding points on the graph. What do you observe from the graph? We observe that the graph of a linear equation in two variables is a straight line, and the point 60, 20, which is the solution we got, lies on the line representing the equation x plus 3y is equal to 120. Geometrically, we can say that every solution x, y of the linear equation in two variables ax plus by plus c is equal to 0 corresponds to a point on the line representing the equation. Now, let us tabulate the values of x and y for the second equation, x is equal to 3y. To find this out, let us plot the points corresponding to the second equation also. We observe that the two lines representing the two equations are intersecting at a point, and this is the only common point. What do you infer from this? When two lines intersect at one point, then there is only one solution. That is, this pair of linear equation has a unique solution and is also called a consistent pair of equations. A coach of a cricket team buys 2 bats and 3 balls for Rs 900. Later, he buys 4 bats and 6 more balls of the same kind for Rs 1800. Represent this equation algebraically and geometrically to find the cost of a bat and a ball. Let us denote the cost of one bat as Rs x and the cost of one ball as Rs y. The algebraic representation is given by the equations 2x plus 3y is equal to 900, equation 1. 4x plus 6y is equal to 1800, equation 2. Geometrically, can you say how this pair of linear equations would look like? To obtain the equivalent geometrical representation, we find 2 points on the line representing each equation. That is, we find 2 solutions for each equation. The solutions are tabulated as follows. Plot these points on a graph paper and draw the lines. We observe that both the pair of lines coincides at all points. Look at the equations carefully now. Can you find out why the lines coincide at all points on the graph? Divide the LHS and RHS of the second equation by 2. We get 2x plus 3y is equal to 900. So, both the equations are equivalent, that is, one can be derived from the other. When two lines coincide at all points, then the pair of linear equations have infinitely many solutions. This also means that it is a dependent, consistent pair of linear equations in two variables. The air route from Bangalore to Chennai is represented by 2x minus y plus 9 is equal to 0. And the air route from Delhi to Kolkata is represented by 6x minus 3y plus 10 is equal to 0. Let us represent this situation graphically and find its solution. Here, the air route from Bangalore to Chennai is represented by a linear equation 2x minus y plus 9 is equal to 0, and that from Delhi to Kolkata is represented by the equation 6x minus 3y plus 10 is equal to 0. The solution to each of the equation is tabulated in the table given below. Now, we plot the respective solutions of the two equations to graphically represent the two pairs of equation. What do you infer from the graph? We observe that the lines do not intersect anywhere, that is, they are parallel. This also means that the two air routes never coincide or converge. Thus, when two lines are parallel, then the pair of linear equations has no solution. It is an inconsistent pair of linear equations in two variables.